Let's continue with modeling in the business intelligence. Modeling is like building a model, which mathematical model rather, which can have connectivity among the data, just like machine learning contains, where we have a data and we are going to have relationship. We are going to find relationship among all of this data to build a suitable model in relation with input data only or in relation with the input and output data both. That time modeling is required. So what is exactly meaning of modeling? What do you mean by model? What is modeling? What are the different types of it? What kind of methods, techniques, tools which are used to build the models that we will see here in the this particular topic. So modeling in business intelligence. So BI models and modeling, which play a significant role in transforming raw data into actionable insights for decision making. So our definite outcome of business intelligence is known to us, that we require to make an informed decision from this data. But how these decisions are made? Definitely, whatever previous data we are having, in this data, we should find some insights. We should find some connectivity. So to do this one, this modeling is required. What's the outcome of it? So they will help to analyze, forecast, and interpret data which can be driven business strategies and improve operational efficiency. This is what the outcomes. These are the already outcome we know about business intelligence. But how it's possible with the help of models, building a model and creating a complete model building process under the business intelligence there. We can have that. See, for example, uh, here we have some kind of different kind of models present under the business intelligence. You can say this one. We have different data sources, a database present here. Excel spreadsheet programs are there, or some other external data sources from the network. So all of they are taken here in the data integration process in ETL. We extracted this data, and then we have stored all of this in data warehouse. Even data marts are, data marts means as per the application, as per the type of the data are separated in different location. They are called data marts. And here we have analysis process here, systematic, whatever data is taken, and then we have OLAP cube. This is called a OLAP cube. OLAP is online analytical processing cube, and with the help of it, the novel insights are taken from this analysis and given to the SRS process for reporting it. Reporting surveys are created finally. Sample example. It's a sample. It's not like always every time the models are created in the similar way. What do you mean by this? Let's go in detail and elaborate this concept. Model in business intelligence refers to a structured representation of data, relationships, and processes that help in analyzing business decisions. Means whatever data I'm having, what structure, similarity data is containing, what relationships are there among the data, primarily among the input data or between the input and output data. What are there? That structures are identified in model. And these models are designed to extract useful pattern, trend, and relationship. These three things are taken. Like in pattern recognition in machine learning, same ideas are being used. But what's the outcome? They can support decision-making process. For that purpose, models are taken. So different kind of models are there. These models can be statistical models. They will have statistical relationship between them, like linear relationship is there. They can have predictive models where these models can build the relations and they can use to perform the predictions ahead. They can have optimization model. Optimization means they will have minimum number of resources with maximum throughput generation. That is called optimization models. So this exactly the meaning term model means. But in general, in analytical systems, which business intelligence needs, there are four kind of models are there. It's called data analytics models also. They are BI models also. Terms are used interchangeably in the similar way. Only difference is that BI contains business related data. Four kind of given over here. Descriptive analysis model, diagnostic analytic model, then predictive analytics model, prescriptive analytics model. So as complexity grows, the value of them also growing, increasing proportionally with them. What do you mean by this? See the examples with meaning of it. Descriptive models, which is very commonly used kind of analytical models present. These models summarize historical data to understand the past performance. They can summarize historical data. What do you mean by what is historical data? Whatever data collected in history. to understand past how we have performed well. Correct. They can have trained pattern or KPIs, key performance indicators present in that data. Then may be possible. How it is happened? Like every kind of analytical work in data analysis or BI, business analyst, they can use this previous data to handle, analyze what else happened in the past. That is what we call a descriptive kind of models. Example, a sales report showing monthly revenue is a descriptive model. Okay, how we have performed in the past, month by month, how it was growing, decrementing, stabilizing, or no trends are there, whatever. That's called a descriptive models. All kind of analytical work, maximum number of analytical work rather, is using descriptive kind of models there. Then predictive models. Predictive models are using historical data and statistical techniques to forecast future outcomes. It's like this was happened in the past. Now, what will happen in future? Okay, this was happened in the past. Now, what will happen in future? That can be found using predictive models there. So they are used to find trend events such as customer behavior, sales forecast, market trend, anything. It's like whatever happens in the world is having some kind of mathematical pattern present in it. Do you think that? And definitely it is there. Okay. It's containing some mathematical pattern, some kind of pattern. We just have to find that pattern. Once you found this pattern, definitely it will be used to perform the predictions ahead. So machine learning algorithms comes under this particular type, predictive models. So for example, regression analysis or machine learning algorithm can predict customer churn or sales growth. If the sale is growing in this direction, so how it will grow in future, I can predict it. Predictive models are there. Or as per the health parameter of a particular customer, particular patient's health parameter, we can predict what is the probability to have the diabetes to this person and predict it. But using previous data, we can use that. Using the previous data, we can perform this data to have a predictions ahead. That is what models are containing. Then next we have prescriptive models. These models suggest action based on data analysis and simulation. Prescriptive, course of action. I just mentioned about it. In previous session also we talked about it. A course of action can be suggested based on this. This is called as prescriptive model. So they help in optimizing decision makers by evaluating possible outcome and recommend the best course of action out of it. What is the best course of action suggested? Okay, that will be there under the prescriptive models here. Okay, let's take an example. For example, it includes optimization models for inventory management or supply chain planning. Inventory management or supply chain planning, that is possible. We can have, they can suggest what is the best inventory that we can have, what is the best route that we can have, suggest course of action that can be suggested by them. Next, diagnostic models. Yes, diagnosis will be performed, and the reason behind the particular outcome is identified. Reason behind it. Okay, causes of it that can be found. What is the reason behind the particular operation to perform? That is identified with the help of diagnostic model. Why this has happened? Just like I mentioned, what is happened, what will happen, course of action, and why this has happened. So all these things are there into this four kind of model. For example, diagnostic model could analyze why sales in a particular region dropped and point out key factors affecting the performance. Why this has happened? What's the reason behind it? That can be found by using the diagnostic kind of model. Means diagnosis is done, and the reason behind the thing which has happened is found with the help of diagnostic models there. It's called a models. Now, what is modeling? Modeling is the process of designing and building the data models, which is essential for BI systems. Designing and building the data models. What is modeling? Now, three things are there in it. Three steps. Like first, organize it. Second, structure it. And third, analyze it. Organize, structure, and analyze the data to extract meaningful insights from there. That's called as modeling. A common steps of process being followed for building the model. So primary goal of modeling in BI is to make complex data more understandable and accessible for decision makers. Yes. Okay, so whatever complexity that data is having or data is involved with, that complexity can be reduced, probably removed, and then make it usable for using that data in any appropriate situation. Once the data is made appropriately suitable, so model building can be easily possible, or we can have ease in generating the novel insights for the respective kind of data. What are the steps present in it? Many steps are there. 6 7 steps are rather can have. Generally, okay, whenever you see machine learning algorithm, what are steps are present in machine learning? Exact in alignment to machine learning, same steps are present here too. Data collection. So first step in modeling is gathering a data from various sources, including transaction systems, external databases, and third-party services. So as I mentioned, it's a fuel of business intelligence. So in order to build that BI model, so definitely our fuel, what is our fuel? Our fuel is a data. And where can I get that? Yes, external databases, maybe in transaction system, maybe in predefined databases or third-party services. Depending upon the kind of application or model that you're creating, your data source will change. Data collection first. Second, data integration. After collecting the data, it needs to be integrated into common format. Definitely, because algorithm single hai. Algorithm assumes the data to be in a similar format, to be in the similar or to be in the common format there. And that's what the next step data integration needs. This integrated common format often involves data cleaning, yes, data cleaning, data transformation, data combining from multiple sources to a single data model. All these things are possible here. That is data integration. Next, data structuring. Yes. So we require to restructure or structure our data into a common format. So data into structured formats such as tables or multi-dimensional cubes, or lab cubes, like it has shown in the diagram previously, is an essential for effective analysis. For example, dimensional models are created using fact tables, like data tables in sales or revenue, and dimensional tables are there, which contains time, location, product. These terms are basically used very commonly in data structuring. Then data analysis. Here we'll commit analysis. In the previous topics, we talked about it, analytical models presented. Once the data is structured, BI tools perform analysis often through data mining, statistical analysis, machine learning to identify trend, relationship, and pattern. Trend, relationship, and pattern. This is what model basically requires. So models require this. Once they are identified, then can be used to perform the predictions ahead. Next, dimensional modeling. Now, a method of structuring data for fast querying analysis, dimensional modeling. It organizes data into fact tables and dimension tables. Uh, Often with, I hope maybe in database management system, you have learned about it, fact table and data dimension tables, which will be used to store data in well-organized way. Generally for data online analytical processing, we use this particular dimensional modeling. Star schema, star. Like there are 5 different ways are there by which dimensions can be sorted. So in type of dimensional modeling, where a central fact table is connected to multiple dimensions, like a star-like structure. Star-like structure is there, which is easy to understand and support quick querying. Quick querying is immediate result generation is possible from that's called a star schema. One more technique is there, snowflake schema. It's a part of database management system actually. Snowflake schema, something different where these dimension tables are normalized into additional related tables and useful for optimizing storage but can complicate the queries possible extension. One more thing you may have learned about database management DBMS is ER diagrams, entity relationship models, where entities are there and among them whatever relationships are present, that is modeled. So ER modeling is used to represent the relationship between different data entities. So how this entity and that entity are related to each other, like customer and product are there, how they are related to each other, what kind of relationship that they are having. These things are modeled by ER diagrams. It helps in building normalized databases by identifying the entities and relationship between them, customers and product, how they are related. Then OLAP cube modeling, which was also shown. You can see multi-dimensional analysis when data is in cube format. So we can allow slicing and dicing for fast curing possible. It's like a special situation where multi-dimensional databases are present. There, this kind of modeling is used. Next is predictive modeling. Yes, what you are saying? Predictive analytics, same things are here. So this predictive modeling involves use of statistical algorithm or machine learning techniques such as regression analysis, classification algorithm, clustering algorithm to forecast the future trend and behavior. Okay, this was happened in the past. Now what will happen in future? That we are going to find under the predictive modeling. Correct, same concept. Yeah. Yeah. So why this is important? These are the kind of modeling methods, process are there. We'll go in detail and dig the deep insights in building the process architecture. There are various ways by models are created. That also we'll see. Why it is important? First thing, the data organization. So BI models organize large and complex data set into manageable and understandable format. We know this is one of the best way to organize the data in easily suitable way. Then saying informed decision making. Definitely outcome of every BI process is the same. So models in BI provides actionable insights, helping businesses to make more informed and data-driven decisions. That is informed decision making. Or we can have efficiency and accuracy from the same. I want data to get efficient and accurate results. Okay. So proper BI modeling techniques enable quicker and more accurate data analysis. How? By reducing human error and improve decision quality of it. That's possible. Trend analysis. That is one of the outcome of the modeling there, and that's why it is important. The predictive models are built and other BI techniques are also available that help to identify emerging trends, forecast future performance and prepare for upcoming challenges. Trend analysis that can be done. Now how can I build the model? Model building is a systematic and well organized process which is being followed in the business intelligence. So some very common steps that we have to follow over here under building the models. See, so model building refers to the process of designing and creating a data model that enable organization to structure, analyze and derive novel insights from the data. That's why model building is necessary. The reason why it's required there. And these models help in organizing raw data into a form that is easier to interpret. Means what easiness we require. By looking at the data, by looking at the model which are created, we should easily understand what it internally contains. So interpreting, analyzing, and visualizing, which allow decision makers to make a data-driven decision. For that purpose, model building is required. Remember. Now, purpose. The reason of it. I will elaborate again in detail. So goal of this is to convert complex raw data into structured data format. Organized, structured or organized, well organized. Maybe not structured data is also present. But generally, whatever algorithm that we are currently using in machine learning and deep learning, predictive analytics, discriminant analytics, they all require structured data, not unstructured data. So that's what structured data is required, which supports decision-making systems where these models can perform this four kind of work. Which one? Organize and structure data for efficient querying and analysis. First purpose. Second, trend, pattern, and relationship identification by which informed decisions are possible. Then improve reporting and visualization of data for business users. Reporting and visualization of data. That is possible for the business users. And last, okay, definitely prediction, decision making is an outcome. Predict future outcomes and forecast trend for better planning. That's done with the help of the model building there. Now, what are the steps present here? A common step whenever we build a model, it's like a building a model by applying the machine learning algorithm. There is a similar steps are there, which are being followed. So there are total 7 steps are present, which by which the model building can be done. And where primary we are going to have the brain is the machine learning kind of algorithms or the algorithm which will come under data mining process where predictive analytics are possible. These models can be created. The first step is data collection. Again, come to the general idea. That is, they require fuel. That is, the fuel is data. Step number one is data collection. They gather the data from various sources, including transaction databases, external data set, data warehouses, where we are employing the ETL process, extract, transform, and load process to collect and clean the data, extract it. So create an appropriate suitable technique. With the help of it, we can extract the data for building the model. We can transform in a required format for us, and we can load it wherever it is required for building the model there. Okay, that's step number one. Step number two is data preparation. We prepare the data. Prepare. It's not like the data is collected and given to the model. So model is built. They can do the prediction. They can do the description. They can find diagnosis. They can do prescriptions. Not possible there. Because we have to represent data in a format which is easily understood by the model, and for that purpose data preparation is required. There are three steps present in data preparation. First is data cleaning, second is data transformation, and third data integration, which can be done in building the model. What is data cleaning? Means data may be not available in appropriate format required by the algorithm there. It may contain relevant, irrelevant, inconsistent information inside, or maybe having missing data also present in it. So we have to recover from it. Recover it. See, in order to recover that, data cleaning is required. So there are various techniques, steps, normalization methods present by which data can be cleaned. Data transformation, second. Again, maybe data is not suitably present in the appropriate format. You have to transform data from one form to another form. So transform this raw data into more suitable formats, such as aggregating data, creating calculated fields, or joining data from multiple sources. We transform it in the suitable format there. That's part of data transformation. Data integration. Integrate the data from various sources to ensure consistency and create a unified data set there. Okay, consistency, integrate from multiple sources and create a unified data set, common data set which will be used. For example, I have taken temperature from various locations. In one of the location, temperature is in centigrade. In another location, temperature is in Fahrenheit. Can I have unified data there? Yes. Either you have to convert centigrade to Fahrenheit or Fahrenheit to centigrade, then they can be combined together. So like this kind of process, consistent techniques are present by which data is prepared. One of the crucial steps. If it is done so perfectly, then only model will be done perfectly there. That is data preparation method. Next, data modeling. Here, actually, we decide what kind of models are available and presented there. See this. First of all, you have to define relationships. Okay. Create a relationship between different data entities. For example, define how customer table reflect the sales table, how they are affecting each other. Maybe we need to have some suitable method to find linear relationship present there or not. Correct? Relationship. What kind of relation they are having? Which kind of data is input? Which kind of data is output? So what kind of relationship that they are carrying? Linear, non-linear, polynomial, logistic, which kind of? That you can find by suitable numerical method, mathematical methods there. Then dimensional modeling. Can use dimensional modeling technique like star schema, snowflake schema to organize data into fact and dimensional tables for efficient analysis. So like fact table contains the quantitative data, and dimension table will contain the descriptive attributes. Okay, quantitative data means sales revenue, quantitative numerical data, units sold, how much are there. And dimension table will contain descriptive attributes like product, time, location, and all of this data will be there inside dimensional modeling. And even it contains multi-dimensional modeling also. Multi-dimensional modeling, multiple features are considered, like design OLAP cube for quick dimensional analysis, which allows slicing and dicing of data to analyze it from multiple perspectives, maybe by time, by geography, or by product altogether. That is what data modeling requires. Once the model is built, we can use different evaluation methods to find the accuracy of it, effectiveness of it, and we test them on some unknown data which is not known to the algorithm there. So first of all, we check the performance of the model. We evaluate the model to ensure it produces meaningful and accurate results. Meaningful and accurate results are taken out. That is what we check the model's performance. We can test. Testing might involve running simulations or comparing the results with historical data. Okay, that's also possible. Ki whatever, how do I know the model is performing better and up to the mark as per the requirement of the algorithm? Then how do we know about this? For this purpose, we have to implement some suitable methods there for finding. I'll show that we are having model assessment separate topic there. With the help of it, you can see how to evaluate this model to ensure it produces meaningful and accurate results there. So testing might involve running simulations on comparing results or historical data. Historical data is also present, like we are having 10 data and testing data by which the splitting is possible. I'll show that how to do this one. We can have and testing. Correct. So refine the model. Refining the model, modify the model by fine-tuning relationship, adding new variables, or adjusting the algorithm for better accuracy. They all are possible. Correct. Fine-tune the relationships means maybe feature A and feature B are related, but feature B and C are more accurately related. Or we can change their scale. That is also possible to have fine-tune. Even add new variables. There's a technique called as principal component analysis by which new variables can be added. Some can be removed. And we can adjust the algorithm as per the accuracy. These are the step number 4. Step number 5, deployment. That is model implementation. Deploy. So deploy the model. Once the model is finalized, deploy it in a BI platform where end users can interact with it, generate reports, or analyze the data. So two kind of deployments are there. First, whether it is a desktop deployment or it can be a web deployment on a single system or on the web system, in the cloud system also. Deployment is possible where they can collect the data and perform all the steps and then perform the predictions, generate the novel insight from it. It's possible. Automation is a part of it. Automation is automate the process of data updating and model retraining. See, this is what iterative process contains. Whatever model I have created is based on the current data, but maybe this model will get changed continuously as new data comes into picture. It will get changed iteratively as new data comes into picture. Again, change, update it, retrain it, update it, retrain it. On a daily basis, the model is getting new data, getting modified accordingly, getting more and more accurate results out of it. That's what automation does. Okay. And step number 6, visualize and reporting. We can use BI tools like Power BI, Tableau, or Click to create visualization that make it easier for stakeholder to understand the model's output. Understanding model's output is your customers customers or stakeholders can identify the model's output. Dashboards, charts, and reports are the key to communicate the insight. What you learned, what you identified, what you understood from this, that will be visualized with the help of different visualization and reporting tools like the name which are given over there. That are the commonly used steps present over here. Okay. See, one topic which one step which I mentioned here about the evaluation of this, or can we check how accurate the model is created? So for that purpose, we require to know about the model assessment process. If you align the same step with the machine learning algorithm, they are almost similar steps are present for BI and machine, because BI is itself is a part of machine learning which is taken, and similar kind of ideas being used there. So model assessment and quality are crucial aspect of this BI models, whether the model is designed for predictive analytics, descriptive reporting, or prescriptive decision making. Ensuring that the model is accurate, reliable, and usable is essential for its success in real-world applications. You should know how much useful the model is. We have to assess the effectiveness or accuracies of these respective models there. Now we evaluate the performance and effectiveness of it. Two things are there: how well the model is performing, and what is the effectiveness of it. What is the accuracy of it? Effectiveness on various situations that can be identified in the model assessment, which involves analyzing how well the model fits the data. First thing. Second, how it meets the business objectives, at what extent it meets the business objectives, and it performs in real world scenarios. How well it performs in real world scenarios. That's done in the model assessment panel. So the assessment ensures that model provides accurate, actionable insights and can support decision making, because we know whatever decision we made, on what basis is made, how accurate the data was giving the decision, the model was giving decision on respective data, that will be found. And using that, the predictions are made, which is called as model assessment. So how do we assess it? There are 7 steps present by which model assessment is possible. See this, these are the steps given over here. Step number 1, define the objective of the model. For what purpose, what aim we are creating these models? We establish clear objectives for what the model is meant to achieve. Number 1, for example, the goal is to predict future sale, understand customer behavior, or you want to optimize the business process. What is your goal? That's what we have to know. Then make sure that the model aligns with business needs and decision making requirements. Whatever model we created is aligning with the thing that we need, or whatever our requirements are there, it's aligning with this. Number 2, evaluate the model's accuracy. Now see, if we talk about the machine learning models, they are evaluated with the help of certain numerical methods, which is being implemented exactly in the same way here also. See, models accuracy. So accuracy is one of the most basic metric for assessing models, and particularly for predictive modeling. Predictive is when they are predicting some kind of outputs. Predictive models. So integration modeling, this could involve metrics such as MAE, mean absolute error, that is regression models, or root mean squared error, RMSE, or R squared error. Regression models, they can be used, means whenever I want to do the predictions. See, for example, uh, the cost of a product is based on the inflation rate. They are regression model. I want to predict the cost of a particular product based on the inflation rate. So inflation rate is input variable, cost of product is output variable. So we can use a method called as mean absolute error, how much average difference is present between actual value and predicted value. Absolute difference between, that's called as mean absolute error. You can see it should be as low as possible. Then root mean squared, RMSE. Root mean squared error. Same idea. How much average error is present between actual and predicted value is root mean squared error. That can also be used as a evaluation method. Or R squared error. R squared error especially is for linear regression. How on average the line is away from the mean. That's called a R squared error. That is to check it. Or if you talk about the classification model, the common metrics which are used for assessment are accuracy, means what's the percentage of results are matching, what percentage of results are not matching results. So results are matching, it's called accuracy of the model. Precision of it, recall of it, F1 score of it. I hope you may have heard about this term in machine learning. Or ROC AUC curve, area under the curve. ROC AUC curve. ROC means receiver's operational characteristics. So their curve can be shown, and how much area is under the curve will define accuracy of the respective predictive probabilistic model. That can be checked. So, okay, this is what the methods are there, and in order to accomplish that, we require to use cross-validation technique, like train test split is there, k-fold cross-validation technique, or leave one out cross-validation method. Many techniques are there which are used over there. So they can be used to assess how well a model generalizes to unseen data. That is cross-validation methods used. Number 3, test the model performance. So in order to test that, as I mentioned in the previous slide also, we have to cross-validate the data. Cross-validation is a method by which you convert your data into two forms: training data and testing data. We divide dataset into training and testing dataset to ensure models performs well on test data or unseen data. Means we build a model on the data which is known to you, which is called a training data. Okay, and we evaluate the performance of the algorithm on the data which is not known to you, which is called a testing data. Okay, training data and testing data, two kind of things. Okay, and second technique, first method is called as first method is called a train test split. Okay, first technique is called a train test split method. by which you split our data into two different forms. Okay, we split our data into two different forms, training and testing, which is called as hold out method. Its technical name is hold out method. And with the help of this hold out method, we can separate our data in training form and testing format there. Divide data set into training and testing set. And then secondly, out of sample validation. Out of sample validation means test the model using new data, which is not encountered during training, which assesses the predictive power and generalizability. Okay, generalizability. All things are there, so they can evaluate. See the example mentioned over here. See this. I hope in machine learning also you may have seen these kind of methods. Okay, we have full data set with us. Then from this data, we extract the features. We extract the features. Okay, these are the features taken. Features mean input data and target means output data is there. Right? A model assumes that there is a common relationship present between features and target. There is a common relationship present between the features and target there. Then we split our data into two parts, training and testing. Actually, features means X and target a Y. Okay. And then we split out and training and testing. Training data will be used to train the algorithm. Testing data used to test the accuracy. So you can see this one's mentioned here also. This is your training data. We use this data for training. Okay. Yeah, this one. Training data used for training only. Algorithm will be built on that. Model will be created. And once this is created, we can use this data for testing. That's called a testing data. Okay. We'll test the model. We will check how effectively the model is performing on the respective data that is checked. Step number 3. Then step number 4 and 5, we'll compare again the benchmark. Benchmark means already predefined methods are there. Baseline models are there. We'll compare them. So we'll compare the performance of models against baseline models, industry benchmark, or prior models. This can give you the sense of whether the model provides a substantial improvement in the performance or not. How much improvement you are having means already some baseline models are present. Okay, we can use these models. Okay, we can use these models for performing the predictions. Okay, so we can compare it. This model's performance and means benchmark model's performance, your model's performance. How difference the model performance are there that can be checked. Okay, how different model performance are there that can be checked by this particular method there. Ready? Then finally, step number 4 is done. Then 5. Step number 5, analyze the model stability. How the model is stable means it should generate data, similar results on different kind of data also. Stable model should perform consistently across different data sets, environments, and over the time. Different data sets, different environment over the time. Test for robustness by changing variables or inputs and observe the results. Yes, all kind of. You can have inputs and variables. You can observe the results as per this, and then check this. Number 5. Number 6, assess the model interpretability. For many business users, interpretability and transparency are critical. How do we interpret it? The reasons? It's okay. Which kind of relations are the linear, nonlinear, polynomial, exponential? That interpretation should be made. So models should provide insights that are easy to explain to non-technical stakeholder. If decision makers can't understand why behind the model's recommendation, they may be reluctant to trust it. So there are various tools present which we are currently using in explainable AI, by which interpretation can be found. Explainable AI. Tools like LIME, local interpretable model agnostic explanation, or Shapley additive explanation, can help to interpret more complex models like machine learning algorithms. It will be done. Okay. Number 7. Now evaluate the model scalability. Scalability means how it will be scalable to some n number of parameters, n number of features rather. Okay, scalable, it will increase how many number of features we have. So how you evaluate how well model performs as the volume of data grows. Scale. The amount of data is growing, then how high accuracy of model is getting changed. Scalability. A good model should be scalable, meaning it should continue to deliver accurate insight even with increasing data volumes. If data size is growing, then also the result whatever you are getting should be that much accurate. Perfectly said. That's what assessment step number 7 is present over here. Okay. Now, what is quality of model? So, the term data quality is referred very commonly. What's the meaning of it? What quality basically means, and how do I interpret that quality step by step? So, quality of model in business intelligence refers to how well the model is designed and build optimized for delivering actionable insights. So definitely everywhere, whenever we are using any particular term, the quality will be interpreted differently at different kind of location there. So here in case of the models which we are using, high quality models should be accurate, should be efficient and easy to use and aligned with the business objective. Whatever outcome we are getting, they should be aligned with the business objectives. Basically, they should be aligned with the business objectives. Remember it, and that business objectives are playing a very crucial role over here. Remember, okay. And now, how do I assess the quality of this particular model? So, what exactly the factor which affect the quality of model, which I have shown over here? You can see data quality. High quality data is foundation for BI models. If data is incomplete, inconsistent, or incorrect, definitely result will be unreliable. So we ensure the data is cleaned, pre-processed, and transformed before building the model. That is first thing. Second, accuracy and precision. I hope you may be knowing what is accuracy. Accuracy means in the training and testing data, how much percentage of data are matching. That is accuracy. Correct. So model should be accurate, meaning it should provide insights that are close to the actual values. Predictive model, basically. Correct. And the results should be consistent always. So whatever results we are getting, they should be consistent. Results applied to the new data. So it can be evaluated using metrics like error rate, AUC, ROC score, F1 score, depending upon the kind of model. They are generally used for classification kind of models. Even for regression models, also different models are used. Relevance of features. So whatever features input data we have used, they are relevant or irrelevant. Based on that, also quality of model can be different. High quality models should include relevant features, variables that contribute significantly to the prediction or insights. Okay, features data means maybe some data which are not important. I want to predict the marks of the student, and I'm using roll number as the feature for this. What do you think? Roll number decide the marks of the student? No, roll number cannot decide. That's what we call an irrelevant feature. Means if you're getting a roll number and using roll number, I am going to predict the marks of the student. Definitely, it is one of the inaccurate method present in such scenarios possible. Correct. So high quality models should include relevant features, variables that contribute significantly for prediction of insights. So feature selection method such as stepwise regression, lasso regression, or decision tree based algorithm can help to identify the most relevant features there that also affect the quality of the BI models. Consistency and stability. Now see, the model should produce consistent result for different data set and different conditions. Different data set, different conditions. Different data set means different data, not data set actually. Different type of data where we are having this model perfectly applied. So it should not it should not be over sensitive to small changes in it. Like small changes in the sense ki whenever we are having these cross validation methods, okay, we ensure that the model generalizes well to different type of data samples. Means all kind of data samples will be possible, And for every kind of data samples, it's possible that your data should perform well. Okay, it should perform well on different type of data samples. That also will recognize the ability of accuracies of the respective models over this. That accuracies of the models can be possible that we can have. These are the common factors which are affecting the quality. Next, usability and interpretation. Usability interpretation. So quality of BI model should be easy to use and understand for non-technical stakeholders. For the non-technical stakeholders, those who are not knowing it. Now see, if I am using a machine learning algorithm and I am using a neural network model, okay, it might be powerful, but they can be difficult to explain. Right? Usability is good. So simpler model with clear reasoning, such as decision tree, might provide greater value in certain context. That is also possible. So visualization tools that represent the output of models in unstable way, like charts, graphs, can improve the overall usability of the respective model. That is also possible there. Then models efficiency. Efficiency means how much amount of time we are using or how much amount of resources they are taking to run the model. So least amount of time and minimal resources should be taken by algorithm to execute it, particularly with large data set. So model should be efficient. You can identify that. So high quality models should be optimized for performance and not require excessive computational resources. Okay, they will not require excessive computational resources. So ensure that the model is scalable and can handle large data set or growing amount of data without a significant loss of performance. Without significant loss of performance. That is what efficient models are. Next, and this is what I have carried regularly for every topic. Alignment with business objective means what objective we are focused on to build that model. They are satisfied or they are aligned. They are satisfied with their outcomes is taken out. Not that is taken there. So high quality BI models should be closely aligned with business goals and user needs. Okay, so they should address the problem or challenges identified by business and deliver actionable, relevant insight that are data-driven making. That is final outcome. So if they are all are following, definitely it will be helpful for uh, for assessing the model effectively there. Now, I just mentioned about key performance indicators. So these key performance metrics, they are itself is the indicator with help of it, evaluation of the model is possible. So for two kind of models are there: predictive classification model and predictive regression models. Okay, so they can be used where these conform metrics are used for evaluation. First, mean absolute error. I just mentioned about it. What is that? The average magnitude of errors between predicted value and actual values. Average error. Average absolute error. Difference between the both is called as MAE, mean absolute error. Then RMS, root mean squared error. Same, eh? Average error, but square root of average square difference between the predicted and actual values are taken. But RMSE, I hope you may have learned about it in machine learning. So use there. Then R squared error. It indicates how well the model explained the variability, target variable means linearity, how well linearity is modeled. That is shown by R squared error. Precision recall, precision recall ROC, they are ROCAC, they are used for classification modeling basically. So metrics is the classification where precision measures accuracy of positive predictions and recall measures ability to capture positive cases. Correct? In machine learning evaluation, you may have learned about these particular techniques there. They are applicable in the such scenarios. And ROC, you see, area under the curve, under the ROC was operational characteristic, where it shows how well the model distinguishes between the classes, means probabilistic models, how well they are distributing, means what probability differences are present between positive and negative. With the help of it, the effectiveness, accuracy of the models can be defined. See, they are the classification models. So definitely the last two which I mentioned, they are based on classification itself. Accuracy, percentage of predictions, which are correct prediction out of all predictions, called accuracy. F1 score, which is the average harmonic mean of precision and recall, which was seen previously. And confusion matrix, so you may have heard about this, where it shows it's a contingency matrix, summary matrix table. We show the performance of classification model detailing true positives, false positive, true negative, and false negatives. Okay, that possible in the confusion matrix there. Okay, yeah. So there are various ways by which modeling is possible. Few of them I'll show you: logistic structure, analytical structure, and probability structure. Different ways are there by which the modeling is possible. They can have the ways by which it's possible. See the first method, logical modeling is structuring data in a way that optimizes its accessibility, usability, and integrity for analysis and decision making. That is called a logical structure. So this type of modeling emphasizes the creation of logical representation of data, allow consistent analysis, reporting, visualization, like all these things together. And the logical structure focuses on defining how data should be organized without being tied to physical storage details. Logical, not physical storage. Logically, we organize it different ways. So it typically abstract away from technical implementation details and focuses on how data should be perceived and used by BI systems. Okay, that is logical structure. For logical structure, concepts are there. To organize the data in a file, first format a ontology, second format a frame, which are used here. So what is ontology? Ontology is one of the old format of language where relationship among the data can be shown. So an ontology is a formal representation of a set of concepts within a domain and the relationship between those concepts that is shown by ontology, which provides the structural framework for understanding how entities within a particular domain are related to each other. It's there's a language called semantic web language or ontology web language, where this knowledge can be stored in a file, something like there are some concepts used. See, these are the concepts. Class and class of concept called as, so they are building block. Above we are having one class and under it different subclasses are there. Okay, block of concept of classes like generalized class. Like for example, you can have a common class and a common noun and proper noun present there. You can see this one. Class is a structure, we know. For example, if mammal is a class, bird is a class, reptile is a class. Okay, so if mammal is a class, then lion, tiger, elephant are the instance of it. If bird is a class, then parrot, sparrow, crow are the instance of it. If reptile is a class, then snake, cobra, and all they are the instance of them. So these techniques are used here to represent your data under the ontology web language. So class is top level term. Below under it, we are having different instances present. Instances are the individual object or entities that belong to a class, like this mentioned here. Mammal class instances could be animals like lion, tiger, elephant, and all. And for them, we are having properties or relations, just like object-oriented programming contains. This ontology define how concepts are related to each other through relationships. The relationship can be is a type of, has a part of, or I can see lion is a type of mammal, okay, or lion is having a tail. These relationships are in ontology, they are maintained. And axioms. Axioms are logical statement which defines the constant or rule about the concept or relationship there. Like for example, you can see axiom might be all mammals give birth. Directly they will give birth. Ensuring that any class of mammal in ontology is associated with the giving birth. Everyone is having same rule associated. Axiom is applicable to all of them at a time. That's called axiom. Okay, in this way data is represented. It's called as ontology, and this ontology data is basically stored in a special file format. It's called as the ontology web language. It's called as ontology web language, OWL. Okay, kind of data is present there, and with the help of this ontology web language, representation of knowledge is basically possible. See this one small diagram or one small file I'll show you. This is a OWL file. You can see this ontology web language file. Can stored. It's an XML kind of file. So above we are having a class, one class, and under this class we are having instances of it, and their properties, behaviors can be shown. Okay, see this one. All. Yeah, it's just like a XML file you may have heard about. So you may have seen that XML file, and similar way, that's a markup language. With the help of it, data can be represented in this particular format here. Okay, that's called as ontology web language. But where do we use this to represent the data? Knowledge representation. It was one of the older form to represent the knowledge. Domain specific. Okay, this domain, and under that domain, which classes are possible, which kind of attributes are possible, instances possible, which kind of attributes are possible, which kind of relationships are possible, represented. That's called an ontology web language. So semantic web also is used. Semantic web is whenever I have to understand meaning of the word, that is called as semantic understanding of the language. So there we use semantic web language. In artificial intelligence also, ontology allow AI system to reason about entities, their properties, and relationship between them to make the informed decision. And for data integration also, we are going to use this ontology language. Let's see the example. Ontology for medical domain might include classes, disease, symptom, treatment. Relationship like has a symptom, is treated by, or instances can be flu, or disease, cough, symptom, antiviral medications, a treatment, or exam, like every disease has a symptom, 100%. Then axiom. So you represent ontology for medical domain in this particular format. OW, ontology web language. The second way, it's called as frames, by which data can be represented in logical form. So frame is data structure used for representing stereotyped situation, in basically in AI knowledge implementation, BI knowledge implementation. There, similar to OOP concept again. Similar, whatever ontology, they are also similar to OOP concept. But this concept was introduced by Marvin Minsky in 1974 as a way to represent structured knowledge in the AI system. Okay, that's what we call a frame. See, what frame basically contains? Frame contains first slots. Similar names like class and objects are there. Here we are having a slot and facets. So slots are attributes or properties, the frame that describe different aspect or entity are being represented. Person frame may have a slot like name, age, occupation. Correct? Person frame. Person is a class sign. Under it, attributes are there. The attributes are called as slots. Correct. Then facets. Facets are value or constraints for the slot. The value should be presented between the respective range only. Constraints are assigned to it. They're called as facets. The facets can be specific value, default value, constant on the possible value. You can see this one. Example is given here. Age slot in a person frame may have a facet that limits value to an integer between 0 to 150. The age should not be greater than 150, should not be less than 0. Facet. Okay. Then inheritance. Yes, inheritance is like deriving the properties of one frame to another frame. Inheritance. In object programming, you may have seen this one. So this allows efficient knowledge usage. See, for example, a student frame might inherit the name and age slot from one general person frame. Student is a person. So on person, we have name and age. When you inherit as a student, whatever person properties are there, applicable to student also. Fine. That is inheritance. Then defaults. So everybody have default value. Frames may include default value for some of their slots. This may be explicitly already can see example. Occupation slot may be unemployed by default, but you can change it afterwards. You can make it employed also. Definitely possible. Then what are the features of the frames? Yes, first feature a procedural attachment. Okay, these slots in frame may contain procedures, functions, like object-oriented programming contains functions, which allows frame to represent more dynamic knowledge or behavior. Okay, for example, see this one. A temperature slot in room frame might have a procedure that adjusts the temperature based on certain conditions. For example, turn on the heater if temperature is less than 18 degrees centigrade. Something procedure function which is done doing this work. Okay, they're applicable, available there, but where do we use it? We use it for structural data knowledge representation. Data is in structured format. We can represent knowledge in frames. Just like maybe we have seen object-oriented modeling and design. So in object-oriented modeling design also, whatever classes are defined, these classes are actually frame. They contain instances, they contain variables, they contain relationship among all of them. That is what we represent here in models. Then second, natural language processing. It can be used to represent knowledge about typical sentences, structures, or discourse elements. And then expert systems. We know expert systems are the early form of AI there. So they are commonly used in expert to store knowledge and rules for reasoning about specific domain. And robotic. Today in robotic also these frames are used to represent knowledge in the environments. You can compare them. See this. Difference between ontology and the frame. So formal representation of concepts and relationship with the domain is called as ontology. Frame is structural representation of knowledge, where we have slots and values. Correct? What's the purpose? Purpose is almost similar, but in ontology we have relationship and concept for support reasoning. In frame we are having detailed structured knowledge about an individual entity. Right? So whatever I mentioned. So that is differentiated here between the ontology and the frames. Yeah, let's continue with the methods which are being used. Already we have talked about the methods there, but the common technique which are coming to logical reasoning are here. First method is business process modeling notation. See, whenever we build a business process model theoretically, so some notations are basically being followed there. Graphs are used and some notations are used. So these notations are termed as BPMN, business process model and notation, which represent the data for specific business process in a workflow. That's possible. So they are widely used for modeling business process, enabling the stakeholders such as business analysts, process participant, technical developer, and managers to understand what flow that they are carrying. See this. Okay, just like a flow chart or just like a different kind of chart we use for building the object-oriented modeling. They are used here. So grouping, working group active, something like, and here we have a time. At this time, what to do? It's mentioned here. Then working group still active, yes or no. We are having a diamond shape to decide your make a decision here. Yes, then do this. If it is no, then do this. Then this list is assigned to like all together. Diagram is called a business process modeling diagram, like web architecture. There. This is how these they are basically being built. What they contain nodes for connecting event and activities. Edges are there for flow of process. They are shown by the end. Okay, commonly contain nodes are of different types, just like a flowchart contains. Here also we are having different kind of nodes. So in this context, each task or event is a node. Sequence is present. Gateways are there for making decisions, and swim lanes are present between them. There are multiple type of BPMN are there. The first one is descriptive. The second is executable. Descriptive focus on mapping high-level process to workflow to general understanding how business process works. And executable, they represent more detailed, granular process, fine grained process that can be executed by BPM engine or automated workflow system. That's called as executable BPM. See the example. Small example of BPM. Start event. Order is received. Task to check availability. Yes. If it is available, yes, process to task and make the payment. And if it is not available, process to task, notify the customer. Task is to process the event and order is processed. It's like a simple process which is being followed here in the process management under the transactional methods which are used. So their BPMN is basically being applied. Okay, common notations are used. Node edges and gateways. There you see the form which I mentioned at the end. Start event, check order availability, then gateway, process the payment, and notify customer and end the event. Particularly, the common notations used. Now, second kind of models which are used in the BI are probabilistic model. I hope you have heard about probability concept. Like Even in real life also, whenever you make a decision, we are having certain thing in mind, features in mind, you think about it and you make a decision on probability. I think that I have to take this decision, but I'm sure with 50%, but 50% I'm not sure. Correct. It's called a probability, uncertainty. Correct. So in systems also, when data is noisy, incomplete, inherently uncertain, that time you have to generate a probability. What is the probability? So in business intelligence, machine learning and AI, probabilistic models are used to extensively model uncertain system to make the predictions. But to make the prediction, we are giving the accurate result, certain result where high on which high probabilities are there. We are giving high probabilities. On that side, we are giving the results. Remember, that's what the probabilistic model basically contains. See, there are 4, 5 types of probabilistic models are there. First model is Bayesian network. Maybe knowing Bayesian probability. That's called as Bayesian belief network, BPMN, correct, which contains a DAG, directed acyclic graph, with the help of a probability I shown. What is probability from this node to that node to this node, another node? A complete network is created. It's called as Bayesian network, Bayesian belief network. With the help of it, probabilities can be found. Just like it's an experimental probability based on previous data, the probabilities are taken out. Second, a Markov model. The other hidden Markov models. At the end, I have given there. It's a probabilistic model that assumes the future state of the system depending upon the current state. What is Markov property? Using that Markov models, the probability, the next actions are basically generated, sequence of actions are generated. Let's say GMM, Gaussian mixture model. It is also a probabilistic model that assumes the data point are generated from a mixture of several Gaussian distribution combined there. And you find where do I are having the Gaussian probabilities, that groups are separated, distributions are separated. Fine, and that from mixture we have separated the groups, and we find where high probability of having the data to be in the group. It's called as Gaussian mixture model. Then we are having CRF, sorry, conditional random fields. Okay, they are basically used for structured prediction problem where the goal is to predict the set of output which are interdependent. There we are using this CRF. Probabilistic model. Okay, these all are the part of machine learning kind of algorithms there where we use it and we perform the predictions accordingly. And the last model is analytical model. Analytical model where we are using analysis of something. We have already seen analytical model in the business intelligence session. Okay, they applies mathematical statistical method to analyze the data, system, and process, where they uses formal mathematical structure to represent complex real-world phenomena, helping organization to derive insights, optimize process, and make informed decision from this, where they are using for data analysis, forecasting, optimization, and decision making. We use it. See, so different analytical models are there. Out of it, first analytical model is linear programming, LP, which is very commonly used for optimization process generation, mathematical optimization method. With minimum or maximum number of resources, we should generate the best outcome out of it. It's called a linear programming. Correct, best outcome with the help of maximum of something or minimum of something. Fine, that is called as linear programming model, LP. Even NLP is also there, non-linear programming, something different, where we are having quadratic or exponential relationship present between the data. So optimized result can be possible. That's called as non-linear programming. Means, for example, I have given, I'm having this number of raw material, this number of hours of machines. So I want maximum throughput from the same. So how it is possible? How it is possible? So you have to use this linear or non-linear programming methods to do this. Next, regression analysis. We have learned about it already. We have to find the relationship between dependent independent variables, and using that we are going to find it with the help of linear regression, multiple regression, and logistic regression. This is analytical method. Time series analysis also we have seen in the first session there. It's a part of analytical modeling again. Data which is time dependent, which is collected from regular time intervals, that will be used for building the model collected over the time to understand pattern, trend, and seasonal variations, how the ups and downs are there as per the seasons. That analysis is called a time series analysis. Where do we use it? Okay. And then simulation model. Simulation model is a mathematical process by which you simulate something. Simulate. Okay, I want to simulate the head and tail toss, coin toss. So definitely it's possible to have a random simulation method. With the help of this random simulation method, we can simulate how it is possible to predict what can be the next move of a particular person. So we can have that simulation model. So yes, stochastic elements or random variables are used to perform this operation there. Yeah, there are the common analytical methods used. Now, very important things to note that how do we generate the data for building all of it? Because data is a fuel for these all analytical systems. How it is possible? There are various ways that we can follow to generate the data. So process of creating data from various sources or method for analysis, experimentation, or testing purpose for data generation. Simply. So whenever we require this data, we can generate data by various methods. For a common method, real world data generation, where data is collected from transaction, user interaction, sensors, continuously. And then we use it to build your model. Second is synthetic data generation, where we use artificial method for generating the data. Machine learning models are there. Testing and simulation methods are used there to perform these operations. So we can use this for proprietary information to generate the data. That's possible to work on it. We can generate easily. For example, generating a fake data for customer database and simulate financial transaction. That's possible. Third, random data generations, where we use some methods like Monte Carlo simulation methods to generate the data, or random sampling can also be applied and used there to generate the data. So Monte Carlo is a common method to generate the data. A/B testing simulation methods are used. Or we can use simulation based. There are again Monte Carlo simulation method by which we can simulate the data from original available data, and agent based method, which involves creating artificial agent that is following predefined rules, and with the help of predefined rules, they can interact with the real world problem. That is also possible there. And last, rule based data generation. Certain rules are there. Okay, creating data based on rules for logical relationship between the variables. We can have some rules are given there, and accordingly, randomly data will be generated there. One more parametric data generation, where you having parameter key mean, variance, standard deviations are given, and which follow that data, only that data will be generated. Something like these techniques are basically being used. Augmentation, common method. Augmentation means recreating data from original data. We recreate the data from the original data. It's called a data augmentation method. Maybe if you have learned about it. For images, flipping, rotating, adding noise is possible. For text, rewording sentences, adding synonyms, introducing noise. For time series, adding noise, shifting time series data. So like all these techniques are used, means you recreate it. That's called a data augmentation method, which are used to generate the data for building the model. Fine. So these all things are required for understanding and building the models here. Let's come to the conclusion. Whatever we have learned, real about data modeling, which is a process that transforms raw data into structured format, which enable organization to derive valuable insights. Correct? Where this modeling basically enhance decision making, optimization process, and improve operational efficiency. That's what we basically require. And definitely, robust data models support informed strategic decisions for long term business growth. That's what we are understanding technically from the term which we have learned from this. This is what exactly data modeling concepts are meaning. They are used practically for learning from the data and finding useful insight for performing all kind of analytical methods, a real world scenario for growth of our business.